continue with tissues with connective tissue. So connective tissue is the second type of tissue. It's the most abundant, widely distributed, and it's the most variable types of tissue. And there's four fundamental classes of connective tissue: cartilage, bone, blood, and connective tissue proper. That is the tissue that actually connects things together. These things have more in common than what you first think about. Like in terms of skin and bone, seem like they're radically different, but they're really not. They are very much the same sort of thing. There is connective tissue proper is made of collagen fibers, and there's subtypes. There's loose and dense. So the loose is areolar, adipose, and reticular. The dense is regular, irregular, and elastic. Cartilage, there's three different types of cartilage: hyaline, elastic, and fibrocartilage. There's two different types of bone: compact bone and spongy bone. And there's only one type of blood. Blood is a liquid connective tissue. So we'll go over each one of those individually, but that was kind of the overview. So what's the functions of connective tissue? The major function is binding and support. That's why it's called connective tissue, binding things together. It's involved with protection. It's involved with insulation. Fat is connective tissue. It's involved with transportation of gases, of nutrients, of hormones, that kind of thing, because blood is a transportation medium, and it is connective tissue. So how can we tell when we're looking at connective tissue? So the functions are one list, and the characteristics are another. So this is the characteristics. Connective tissue all has mesenchyme as their tissue of origin, so it's all from the middle part of an embryo. But you're not going to know that by looking at it. This one kills me. Varying degrees of vascularity. So that means that connective tissue is highly vascular unless it's not, unless it's avascular. It's everything in between. Cartilage is avascular. There's no vascularization in cartilage, no blood in cartilage. Bone is super highly vascular. And connective tissue proper varies in the amount of vascularity that there is. So really, those first two things, mesenchyme and degrees of vascularity, don't tell you squat. There's nothing that you can take from that. So really, what are we looking at? The third thing, and this is what they all have in common. There's relatively few cells, and there's a whole lot of stuff that is outside of the cells. It's non-living. It's called matrix, extracellular matrix. And matrix is made up of two things: ground substance and fibers. And the nature of the ground substance and the nature of the fibers dictate the nature of the matrix, and the nature of the matrix dictates the properties of that connective tissue. So ground substance. So this is the adhesion proteins, the glue. There's interstitial fluid in it. There's proteins and sugars. Ground substance is fairly wet. Now there's going to be varying degrees of wetness in the ground substance. So cartilage is very wet, where bone is not. So, and blood is completely wet. The ground substance is liquid. It's blood plasma. And in the fibers are really proteins. They're fibrous proteins. And there's three types of them. And it's interesting, I'll throw this out to you. Whenever I see a list of 3 things, um, it really begs for a multiple choice question. Which of the following is not? Because multiple choice questions have 4 detractors, and there are 3 types of collagen, or there's 3 types of fibers. So, which of the following is not a type of fiber found in connective tissue? Collagen, elastic, reticular, or Georgian fibers? Like, so we can, it begs. So anytime you see a list of 3 in any subject, think in terms of, oh, that's a good multiple choice question. So, one type of fiber is collagen. Collagen is a hugely abundant type of fiber in the body. It's a very strong protein. It's very good at tensile strength. You can pull on it, it's like a rope. But you can't push on it, it's like a rope. So it provides a lot of tensile strength. Elastic fibers are actually like springs or phone cords. They are coiled up, and so when they are subjected to tensile strength, they will stretch and bounce back. So they are elastic. The third type of fiber are very thin, fine, short fibers that make up networks. They're called reticular fibers because reticular means net-like. So there's all these types of fibers found in connective tissue. Which one predominates and what's the ground substance made of dictate what's going on. The cells are mitotic. They get they reproduce, and they secrete. And any cell that's a secretory cell is called a blast. So an osteoblast secretes bone matrix. A fibroblast secretes collagen fibers. A chondroblast secretes cartilage. So hemocytoblasts are responsible for blood cells. Mature cells that are found in the tissues are maintain the tissues. So these would be fibrocytes, chondrocytes, osteocytes are them. Now, it's probably useful to think of blasts as being construction crews and sites as being maintenance crews. The blasts make the structure, the sites maintain the structure. So in any given connective tissue, you're going to see blasts and sites and different fiber sites and different ground substance and more or less water. So it kind of all just ends up being a mix. But when you look at it under a microscope, what you are seeing is relatively few cells and, relatively speaking, a lot of matrix. We don't really care about the mesenchyme, but it's an embryonic connective tissue. It's the start of all connective tissue. So when we look at connective tissues, we're going to note what it looks like, what it does, and the location. You'll notice that this is the exact same slide as the overview to epithelial tissue, and it's the same thing, description, function, and location. So when we look at connective tissue proper, there's 2 types, loose and dense. In the loose connective tissue, there's relatively more ground substance than than fibers, and in the dense there's more fibers than ground substance. So a loose connective tissue would be areolar, which is a very common connective tissue with lots of space in it. It even sounds like it's got space in it, areolar. Adipose, which is fat, and reticular connective tissue, which is like a net-like connective tissue that is where a lot of immune functions are found, because there's a lot of empty space in it. The dense connective tissue is dense regular, dense irregular, and dense elastic. So the dense regular, all the collagen fibers are running in one direction. In dense irregular, the collagen fibers are running all over the place, and in dense elastic, there's elastic fibers so the thing can stretch and bounce back. So we use dense regular where the pull is always in one direction. So things like ligaments and tendons tend to be dense regular. Dense irregular is used where there is pull in a lot of different directions. So it ends up being like particle board or chipboard, felt, paper, that kind of thing. So the tension comes on a lot of different angles. So this would be things like parts of the dermis of the skin. There would be, we'd find this in the fascia surrounding muscles and that kind of thing. Dense elastic is probably more like the dermis of the skin, where it's going to be able to stretch and bounce back. Now, when we look at it, the areolar looks like this, and you can see that the collagen fibers are these thick, dark strands. The elastic fibers are these kind of black lines. You don't even actually see reticular fibers in it, and there's relatively few cells. There's a lot of, and there's more space than there is fiber. So that's what makes it loose, and that's what makes it connective tissue. Adipose is loose, and all those big vacuoles contain fat. You don't see a lot of cells. You see mostly non-cellular stuff. Loose connective tissue reticular, again, you're seeing the reticular fibers in black here, and a few cells, lots of white blood cells and stuff in the spaces. We see this in places like the spleen and in the appendix, thyroid, or thymus, places like that. Dense regular, all the collagen fibers are packed together, and they're all running parallel to one another. And now you can see that you're seeing way more fibers than ground substance in this, and very few cells actually. So this would be a tendon or a ligament, and you can just see that this would resist tension left to right, but up and down on this picture it would just fray and separate. So it's designed for pull and pull in one way. This is dense irregular, and one of the things that you'll notice is there's lots of collagen fibers and they're running every which way. It's more random, so it can resist stresses in all directions. Not as well as the regular does in one direction, but this is a good compromise on things that will expand and contract and be pulled in multiple directions in different movements. So the joint capsule of the joint, fascia around the muscle, that kind of thing is that. The elastic ones, you can see how wrinkly it is. So this would be anything that needs kind of to bounce back. So the walls of the aorta would be dense, elastic connective tissue. We call it the elastic lamina. It's what maintains the pulse. When you're feeling any artery with a pulse, you're going to get it. There's some ligaments in the spinal column that need to stretch when you bend forward. It's called the ligamentum flavum, and it's made of this stuff. It tends to be yellow in color. Flavum means yellow, so that's why. It has the consistency of squid, of calamari. It's overcooked calamari is a perfect example of a dense, elastic tissue, connective tissue. So, before I get into cartilage, I want to talk to you about something called reinforced concrete. I know that you probably know of it, but what reinforced concrete is this. Concrete, cement, is really a whole bunch of sand and pebbles glued together. The Portland of the cement is really glue, and the aggregate, the stones and the pebbles and the sand are really the particles that get glued together. And when you do that, when you glue together the aggregate, you get something that is very, very, very good at resisting compressive forces. The forces, you can push on a cement block all you want. You can build a whole house on cement blocks, and they will be fine. Because the harder you push, the more you squeeze the little particles together, and the more it resists that push. So very, very good at compressive strength. But if you pull on a cement block, you break the bonds, you break the glue between the little pebbles, and the thing just shatters, it cracks, it comes apart. So cement, if it is forced apart, if it undergoes tension, breaks apart. Steel bars or steel wires are very, very good at tensile strength. You can pull on them and pull on them and pull on them, and they will resist that pull. But if you push on them, they'll just bend and fold, and so they're very good at tension, but they suck at compression. So if what you do is you lay down a whole bunch of rebar, steel rods, in a pattern, and then you pour cement over it, what you get is a new thing. It's called reinforced concrete. And what it is if you push on it, the concrete will resist, the cement resists the compressive force, and if you pull on it, the steel rods that within it resist the tensile force, and so now you've got a new material that can resist both. So connective tissue is really that. The connective tissue proper really is all steel rod, and like it's all rebar, and not very much ground substance. The ground substance is the cement. The rebar is the fibers. So now when we get into the cartilage, we look at the different types of fibers, and all the ground substance is the same. So picture reinforced concrete with this. So when we look at something called hyaline cartilage, what it has is the chondroblasts are secreting the matrix, and the matrix is ground substance, and the fibers within it are fine reticular fibers. And so what you're seeing is mostly ground substance. It's mostly hyaluronic acid, and it sticks together and is given its form by a very light network of fibers. And what this ends up becoming is almost like a plastic or a Teflon. It gives it a very smooth, slippery surface. So we use this in places like joint ends and things where we want that lack of friction. We want some support. It's not very good at putting up with tensile strain, but it is pretty good at compressive, and that's why we use it in joints, because bones tend to push together. The ligaments prevent them from coming apart. So hyaline cartilage is useful for its smoothness. There's a cushioning. It tends to be very wet, so there's a cushioning. It's almost like sponge. Elastic cartilage is there's fibers in it. There's still the chondrocytes, and you'll see that each chondrocyte in both of these, and actually all three of them, live in a little lagoon. It's called lacunae, an area that is filled with interstitial fluid that nourishes the cell and doesn't have very much matrix in it. So there's the chondrocyte that you see in the lacuna, and in the matrix you're seeing the hyaluronic acid, and you're seeing these elastic fibers. So this is cartilage that will bounce back. So like the outer part of the ear, the epiglottis, things that get flexed a lot, and you don't want them to break. The third type of cartilage is something called fibrocartilage, and the fibrocartilage has got a lot of collagen fibers in, so it really is very strong against tension, and the matrix has enough ground substance in it that it's pretty good against compression as well. So we use this any place where there's going to be shock, where there's going to be sharp blows to it. So like in the discs of the spine, in your knees, in your wrists, in your jaw, there are places where we will find fibrocartilage. The thing that you see is the chondrocytes in the lacunae. You see the ground substance, and you see the collagen fibers. Now, this looks very similar to a dense, regular connective tissue, but there is more ground substance. You can see more space filled with the ground substance than you do in the dense regular. So that's why it's cartilage. And it's fibrocartilage, one word, not fibro, but fibrocartilage. When we look at bone, bone is exactly like reinforced concrete. There are bone cells, chondrocytes, in lacunae, but the ground substance is actually mineralized salts, and the fibers are called osteoid. They provide the framework within the mineralized salts, and so these are unique in that they resist tension and compression. There's another type of bone, but we will talk about it in the next chapter when we talk about bones. Blood is some cells and blood plasma. The blood plasma actually is the ground substance, is predominantly ground substance, and that ground substance is liquid, so that's why it's a liquid tissue. There are fibers in it that are actually proteins that are globular in nature that will turn into fibers when the blood clots and becomes a semi-solid. So that's an important connective tissue.